Hello everyone. Today we shall be discussing on the specific factor model. This model was initially discussed by Jacob Wiener. It was a variant of the Ricardian model and hence was often referred as the Ricardo-Wiener model. The specific factor model was later developed and formalized by Jones and Musa. In the Ricardian model, we have seen that the trade is mutually beneficial for all the participating nations. Trade has substantial effects on the income distribution within each trading nations. Now, there are two reasons why trade has effects on the distribution of income. Number one, resources cannot move immediately or costlessly from one industry to another, and secondly, industries differ in terms of the factors of production that they require. The specific factor model allows the trade to affect the income distribution. Now, we have seen in the Heckscher-Ohlin model that trade acts as a substitute for the international mobility of factors of production. So, although in the Heckscher-Ohlin model, the factors of production are mobile within the sectors in a particular nation, they are immobile across the different countries. However, the factor price equalization theorem states that the absolute as well as the relative factor prices will equalize after the free trade. So, therefore, free trade not only equalizes the commodity prices, but it acts as a substitute for the factor mobility. That means that after free trade, the factor prices will be equalized across the nation. Now, this specific factor model is a short-run version of this Heckscher-Ohlin model. In the Heckscher-Ohlin model, the factors are perfectly mobile across the sectors, whereas in the specific factor model, we assume that some factors are specific to certain sectors. Now, before we move on to the details of the model, we consider the assumptions on which the model rests. So, number one, we consider one country that produces two goods. One is the manufactures and secondly the food. So, initially we shall start from the home country and then we shall be introducing the other country also. So, we are assuming secondly that there are three factors of production: labor, the capital and land. The manufacturing sector production requires capital and labor but not land. So, let us assume that Lm is the amount of labor that is used in the manufacturing production. Food production requires land and labor but not capital. So, we assume that Lf is the amount of labor used in the food production. For the entire economy, the total amount of labor is given. Labor endowment is given and labor is a mobile factor that is used in either sector. So, therefore, we have Lm plus Lf is equal to L, and since labor is mobile across the sectors, so only one wage rate will be prevailing in the particular economy. So, wages will not differ across the sectors. Now, we come to the two other factors. Land and capital are called specific factors that can be used in the production of only one good. So, that means land will be applicable only for the food sector, and capital will be used only in the manufacturing sector. So therefore no question of equalizing land return or capital return to be equalized. The last assumption is that there will be perfect competition in all the markets. So with all these assumptions, now we shall be moving on to the details of the specific factor model. First of all, we come to the technology, that is, how much of each good does the country produce. For the manufacturing sector as well as for the food sector, there are the two production functions. So let us start from the production function for the manufacturing sector. So this is given by QM equal to QM of K, which is capital stock, and LM, which is the labor employed in the manufacturing sector. So on the first diagram of right hand side, we plot the total product curve of the manufacturing sector. So as LM increases, the employment of labor in the manufacturing sector, if it increases, then the total product will increase, but there is a diminishing marginal productivity of labor. Similarly, we consider the production function for food, which is described as QF equal to QF of T and LF. So here T is the supply of land and LF is the labor employed in the food sector. So on the bottom right hand side picture, we consider the total product of the food producing sector. As LF increases, QF will increase, but there will be diminishing marginal productivity of labor. So we have seen how the marginal productivity of labor is behaving in the two sectors. So therefore we have three equations. Number one, the production function in the manufacturing sector, QM equal to QM of K and LM. Food production function actually, so QF is equal to QF of T and LF, and the labor constraint, which is LN plus LF is equal to L, where L is the total availability of labor in the economy. These three equations will be used to derive the production possibility frontier of the economy. Now, when we draw the production possibility frontier for the specific factor model, we analyze the economy's production possibilities by asking a simple question, that is, how the economy's mix of output will change as labor is shifted from one sector to another. So we start from the variable factor, and later on we shall be using the specific factors as well. So let's see how this production possibility frontier is drawn for the home country. So we are considering typically a 4-quadrant diagram. So on the first quadrant, we are showing QM on the horizontal axis and QF on the vertical axis. So in this plane, we shall be plotting the PPF. Now we come to the upper left quadrant, where we shall be measuring LF along the horizontal axis. So therefore, in this quadrant, we shall be plotting the production function or the total product curve of the food producing sector. So this blue line is light blue line, shows the total product curve, which is QF of T and LF. Now we come to the bottom left hand side quadrant, bottom left quadrant. So here on the horizontal axis we have LF, and on the vertical axis, which is heading downwards, we measure LM. So on this quadrant, we shall be measuring the total labor endowment or the labor constant. Now since our labor constant is LM plus LF is equal to L, this labor constant is shown as a straight line, downward sloping straight line, L1, L2 in this quadrant. So the idea is simple. Given the total amount of labor available, if LM increases so that the manufacturing sector uses more of labor, then the food sector will have relatively less labor to employ. Now we come to the last quadrant, which is the right side downward quadrant. So here on the horizontal axis we are measuring QM, and on the vertical axis, which is heading downwards, we are measuring LM. So once again on this quadrant we shall be showing the QM or the total product curve for the manufacturing sector. So this is shown as the deep blue line, and as discussed earlier, as LM increases then QM will increase. So now using the information in the three quadrants, we shall now be deriving the PPF on the first quadrant. So let us start from point L2 on the labor endowment constant. So if the economy is at L2, then the entire amount of labor will be used by the manufacturing sector. So if that is the case, then we can find out from the QM curve that how much QM is produced by the country. So this will be the maximum amount of manufacturing output that the country can produce. So essentially that will be one of the extreme point on the country's PPF. Similarly, if we start from point L1 on the labor endowment labor constant line, then the entire amount of labor will be used in the food producing sector, so that the country will be producing, we can read from the QF line that the country will be producing at a point say 5, so which is the maximum amount of food that the country can produce. So this point, therefore point 5 therefore is the point which is the extreme point on the PPF. So this is the maximum amount of food that the country can produce. Now suppose we start from any other point which is lying in between L1 and L2. Suppose we start from point 1 on L1, L2. So starting from this point we can find out how much of labor will be going to the food sector and how much of labor will be going to the manufacturing sector. So from the diagram it is clear that OS amount of labor is going to the food sector and ON amount of labor will be going into the manufacturing sector. So therefore we can read from the corresponding production function to find out the food production and the manufacturing product in the produced in the economy. So from the diagram it is clear that M amount of OM amount of food will be produced and OR amount of manufacturing good will be produced in the economy. So therefore if we just draw perpendiculars from these two lines, then these 2 points, then they will be meeting at a point like 1 on the QF-QM quadrant. So this point 1 will be a point on the PPF, because this gives us the amount of food and the manufacturing product produced in the economy when labor is fully employed. Now let us consider another point which is different from point 1. Suppose this is point 2. Now point 2 shows how much of labor now will be going to food and how much of labor will now be going into manufacturing. Now from the diagram it is clear that Now OL, amount of labor, is going to the food production, which is higher than before, and OQ, amount of labor, is going to the manufacturing sector, which is less than before. So from the total product curves, we can find out that OZ will be the amount of food produced in the economy, and OP will be the amount of manufactured commodities produced in the economy. So therefore we get a point like 2 on the QF QM quadrant. So point 2 once again will be a point on the PPF, because it gives us the amount of food and manufacturing product produced in the economy when labor is fully employed. Now if we consider point A and point 1 and point 2, then we shall find that at point 1 the amount of M, that is manufactured commodity produced, is more than the amount of food produced. However, at point 2 relatively more of food will be produced and relatively less of manufactured output will be produced. Now this is because of the fact that when we move from point 1 to point 2, more labor is being used in the food sector. So that is why compared to point 1, more food will be produced at point 2. So therefore, following the same exercise, we can find out another point like 3 and many other points on the QM QF quadrant. So if we join all those points with this with the two extreme points, then we get a PPF which is concave to the origin. So the PPF in the specific factor model is similar to the PPF that we derived under the Heckscher-Ohlin model. However, the underlying assumptions of the two models are quite different. In the Heckscher-Ohlin model, we had one abundant factor and one scarce factor, and it was the factor abundance that was giving shape to the PPF of the country. However, in this case, we are having the variable factor or the common factor and the specific factors, and accordingly the PPF is derived. Well, so now we have derived the PPF, but how to find out the equilibrium point for the country? That is exactly how much of labor will be used in the food sector, how much of labor will be used in the manufacturing sector, and exactly where the country will be producing. So for that, we now move on to the analysis of how much labor will be employed in each sector. So here we start from the demand curve for labor in the two sectors. Since we have perfect competition all around, so therefore the equilibrium condition will be equal to the wage rate, money wage rate will be equal to the value of the marginal product of labor. So therefore, in the manufacturing sector, the equilibrium condition is MPLM, which is the marginal productivity of labor in the manufacturing sector, times the PM, which is the price of the manufactured good. That should be equal to WM, where W is the money wage rate in the manufacturing sector. So this is the equilibrium condition. The left hand side is nothing but the value of the marginal product of labor, which is VMPL. So therefore, the equilibrium condition is VMPL is equal to WM, and this VMPL curve is the demand curve for labor for obvious reason, because we have perfectly competitive market. Therefore, the VMPL curve will give us the amount of labor that will be demanded at different wage rates. Similarly, we derive the demand curve for labor in the food sector. So the wage rate will be equal to the value of the marginal product of labor in the food sector. So therefore, VMPL in the food sector will be giving us the demand for labor in the food sector. Now, as we have mentioned already, labor is freely mobile between the two sectors. So therefore, the wage rate must be the same in both the sectors. And along with this, we have the total supply of labor, which is LM plus LF is equal to L. So this is our supply side, and for the demand side, we have the two demand curve for labor. Let us now move on to this diagram where we find out the allocation of labor. So this diagram has two vertical axis and one horizontal axis. So on this horizontal axis, we are measuring the total amount of labor available in the economy. The origin on the left hand side gives us the origin of the manufacturing sector. So if we move from O to, if we move rightward from the point OM, then actually the employment of labor increases in the manufacturing sector. Similarly, we have OF, which is the right origin rather. So that gives us the origin of the food sector. So if we move leftward, starting from point A along the horizontal axis, then employment of labor increases in the food sector. And this total length of the horizontal axis will give us the total amount of labor available in the economy. The left vertical axis shows us the VMPL in the manufacturing sector and the wage rate, money wage rate of course, and the right vertical axis gives us the VMPL in the food sector as well as the money wage rate. The two demand curve for labor or the two VMPL curves are plotted as downward sloping lines. So they must be downward sloping because our assumption is that the marginal productivity of labor is diminishing in both the sectors. The equilibrium will be attained where, or the demand for labor will be equal to the supply of labor at the point E where the two VMPL curves intersect each other. Hence we get the equilibrium wage rate as W, and we get the amount of L, which is the equilibrium employment of labor. So therefore LM shows, or LEM rather, shows us the amount of labor used in the manufacturing sector, and LF gives us the amount of labor used in the food sector. So with this employment of labor in the manufacturing and in the food sector, we can find out that on the PPF at exactly on which point the country is producing, so that you can find out the exact production point even from this diagram. Now we move on to consideration of price in the specific factors model, and let us derive the equilibrium more formally. The equilibrium conditions are MPLM into PM is equal to W from the manufacturing sector, and MPLF into PF is equal to W from the food sector. So therefore the wage rates are equal. Therefore MPLM into PM should be equal to MPL into PF. So from this we get MPLF by MPLM with a negative sign is equal to PM by PF with a negative sign. The left hand side actually shows us the slope of the PPF. So the equilibrium condition requires that at the production point the PPF and the price line should touch each other. This is what is shown in the diagram. So the red line is the PPF, which is concave to the origin. The price line is shown as the blue line. So this price line has the slope of PM by PF, negative of PM by PF, and this price line is touching the PPF at the point 1. Therefore from the point 1 we can read that Q1M will be the manufacturing output produced in the economy in equilibrium, and Q1F is the amount of food produced in the equilibrium. So this is how we derive the pre-trade or the autarkic equilibrium in the home country. Similarly, we can find out the PPF for the foreign country also, and we can find out the pre-trade or the autarkic equilibrium in the foreign country. But before we move into that, we consider some very important comparative static effects in the specific factor model, and these results will have tremendous policy implications. Now let us consider first of all an equal proportional increase in the prices of manufacturing product and the food product. So we start from this diagram. Initial equilibrium is at point E1, initial money wage rate is W1, and the initial employment is L star. Now we assume that the prices rise by 10%. So that PM rises by 10%. So the VMPL curve in the manufacturing sector shifts from PM1 MPLM to PM2 MPLM. Similarly, PF rises by 10%. So therefore, the VMPLF will shift from PF1 MPLF to PF2 MPLF. New equilibrium will be attained at the point E2 where the two new VMPL curves intersect each other. So what is interesting is that the money wage rate increases exactly by 10%. The employment of labor is remaining unchanged. So what is the impact here on the economy and on the different factor prices? Now here the employment of labor L star is unchanged, so that LM and LF are remaining unchanged. Now wage rate has increased by 10%, PM has increased by 10%. Therefore, W by PM is unchanged. W by PF is also unchanged. Therefore, if we consider the real return to the labor or the variable factor of production, then that is remaining unchanged. Now we consider the impact on the capital owners and the impact on the landowners. Now how do we find out the impact on the specific factors? Now here we shall be considering that what has happened to the employment of labor. Now in the manufacturing sector, the amount of labor used is same as before. So in the manufacturing sector, the other factor, which is capital, is now being combined with the same amount of labor as before. So therefore its marginal productivity has remained unchanged. So this essentially means that the real return to the capital owners is remaining unchanged. So this is coming from the very simple point that if the employment of one factor increases, then the marginal productivity of its cooperating factor will also go up. So if the employment of labor increases in the manufacturing sector, then marginal productivity of capital will go up. And marginal productivity of capital is nothing but the real return to the capitalists in the manufacturing sector. But here what has happened? The labor in the manufacturing sector is unchanged. So therefore, marginal productivity of capital will remain unchanged. Real return to capital owners will also remain unchanged. Similarly, if we come to the food sector, then amount of labor employed in the food sector is unchanged. Therefore, marginal productivity of land is remaining unchanged and real return to the land will be remaining unchanged. So to sum up, what will be the impact of an equal proportional increase in the price of manufacturing and price of food? So the labor, which is the variable factor, is although the wage rate increases in monetary terms, the real wage rate is unchanged. So its welfare is not increasing or not changing rather. Similarly, the real return to the capital owners unchanged, real return to the landowner will be remaining unchanged. Now we may consider a case where the price of the manufacturing good is increasing. So PM is increasing but PF is not increasing, PF is unchanged. Therefore, suppose we are assuming that price of manufacturing good is rising by 10%. So the VMPL curve will be shifting by 10% towards the right. So we get the new brown VMPL curve, and the green one was the original VMPL curve. Initial equilibrium was attained at point E1. So L1 was the optimum employment of labor, so that OM L1 was used in the manufacturing sector and L1 OF was used in the food sector, and the wage rate was W1. Now, as the PM increases by 10%, new equilibrium is attained at point E2. Now here employment of labor changes to L2. Therefore, in the manufacturing sector, labor increases by L1, L2 amount. Similarly, in the food sector, the employment of labor falls by L1, L2 amount. What happens to the wage rate? Wage rate increases to W2. However, this increase in wage rate is less than 10% for simple reason. If initially employment of labor remains unchanged at L1, then in the food producing sector, the wage rate will be remaining unchanged at W1. However, in the manufacturing sector, wage rate will rise exactly by 10%, so that it will be at a point like W3, which is read from the point S on the figure. Now, employment cannot remain unchanged. So, as PM increases, there is a wage rate differential. Wage in the food sector is lower and wage in the food manufacturing sector is higher. Therefore, laborer will shift from the food sector to the manufacturing sector. So, employment cannot remain unchanged at point L1. So, employment finally will increase in the manufacturing sector to OML2, and employment in the food sector will fall to OFL2. So, therefore, wage rate cannot increase by 10%, but it will increase only up to W2, which is less than 10%. So, now given this, let us consider that what has happened to the real returns to the factors of production. So, here PM has increased by 10%, however, W has increased by less than 10%. So, what should happen to W by P1? So, W by PM must fall. However, W by PF must rise because W has increased not by 10% but by say 8%, whereas PF is unchanged. So, therefore, W by PF will increase. Now, what has happened to the laborers as a group? This is uncertain, because on one hand W by PM has fallen and W by PF has increased. So, what has happened to the total welfare of the laborer will depend on the composition of their consumption basket. So, in their consumption basket, if they have more of the manufactured commodities, then they are relatively worse off, and if they have more of the food items, then they will be relatively more better off. Now we consider that what has happened to the landowners and what has happened to the capital owners. Now, in the manufacturing sector, the employment of labor has increased. So, the marginal productivity of capital in the manufacturing sector should also increase. So, therefore, the real return to the capital owners should also increase. Now we come to the specific factor of the other sector, which is food, landowners. Now, employment of labor has fallen in the food producing sector. So, therefore, the landowners must be now worse off because their marginal productivity has fallen. So, therefore, their real return must fall. So, now what is to sum up, what is the total impact? Now, as the price of the manufacturing good increases, then the factor specific to that manufacturing goods sector is unequivocally better off. What about the other specific factor? That is the food sector, for which the price has not increased. The specific factors tied to this sector will be unequivocally worse off, because their price has not changed. And what about the variable factor, the common factor? The impact on the common factor is uncertain. So, on one hand they are better off, and on the other they are worse off. Now, this analysis has tremendous policy implication. Suppose this particular country is importing manufacturing commodity. Now, when a tariff is imposed, then the price of the import competing goods will increase. So, therefore, here what is obvious is the specific factor of the import competing sector will be better off after imposition of such tariff. So, therefore, when a tariff is imposed, import tariff is imposed, then the factors specific to the country's import competing sector will favor the tariff. The specific factor of the other sector, which is the export sector, however, will oppose the imposition of the tariff, because they will be worse off after the tariff imposition. But what about the variable factor? The variable factor will neither oppose nor favor the tariff imposition. The same analysis can be considered when a country goes from autarky to the free trade. Now, as the country goes from autarky to free trade, the price of its exportable will increase, because now the exports will be having a more global market where they can get higher prices. So, now we consider that this is the example of a country which is exporting the manufacturing commodity. So, what happens that the factors specific to the export sector will now be favoring the free trade, that is the capitalists in this case, whereas the factors specific to the import sector, which is now food here, will be opposing free trade. And what about the variable factor? So, they will be just indifferent. So, this gives us a very important result. So, when there is any tariff imposition, then the factors specific to the import competing goods sector will be favoring the tariff, whereas the factors specific to the export sector will be opposing the tariff. Whereas, if the free trade is considered, then the factors specific to the export sector will be favoring the free trade, and the factors specific to the nation's import competing goods sector will be opposing the free trade. The variable factor, however, will be indifferent to both. We may consider the response of output to the change in the relative price of manufactures also. Initially, the equilibrium point was at point 1, where the flatter price line was touching the PPF. Now PM by PF has increased because PM has been increased by 10%. So the price line becomes steeper, the red one. New equilibrium is at point 2, so that the country now produces more of the manufactured commodity and less of the food commodity. The relationship that we considered just now is similar to the Stolper-Samuelson result that we obtain in the Heckscher-Ohlin model. However, the difference is that in the Heckscher-Ohlin model, we have one abundant factor and one scarce factor, and factors are perfectly mobile across the sector. So it is a long run variant. However, in the specific factor model, which is essentially a short run model, we do not get the original Stolper-Samuelson type of result. So what we get is a short run variant where one type of specific factor will gain and other type of specific factor will lose, and the impact on the variable factor is uncertain. Now we move on to the case where the capital stock is changed. So this is like the Rybczynski type of analysis, where we try to find out that what happens if the total endowment of the factors change. So what is the impact on the level of output? First we shall consider what happens if the capital stock is changed, and then we shall consider what happens if the labor is changed. So now we assume that prices are unchanged. Now as the capital stock increases, marginal productivity of labor increases in the manufacturing sector, so that the VMPL curve will shift towards the right. Employment will increase in the manufacturing sector and it will fall in the food sector. In the food sector, actually nothing has happened because capital is not used in the food sector. So now what happens to the money wage rate? Money wage rate increases, but of course less than proportionately. This is because if the employment of labor is unchanged at L1, which is the initial equilibrium level of employment, then wage rate in the manufacturing sector will be much higher than the wage rate in the food sector. So therefore workers will move out of the food sector and they will be coming into the manufacturing sector. So employment will increase in the manufacturing sector and it will fall in the food sector. So ultimately new equilibrium will be attained at point M and wage rate will rise only from W1 to W2. Now let us see what has happened to the real return to the factors of production. The workers now are unequivocally better off because prices are unchanged but W has increased. So W by PM and W by PF will increase. Now we consider the owners of the capital. Employment of labor has increased in the manufacturing sector. So therefore marginal productivity of capital has increased and capital owners are now better off. What about the landowners? The employment of labor has decreased in the food sector. So therefore marginal productivity of land has decreased. So therefore the landowners are worse off. So therefore if the endowment of capital which is specific to the manufacturing sector increases, then the factor specific to the manufacturing sector will be definitely better off. the other sector which is not facing the growth or which is not experiencing the growth will be worse off, whereas the workers, which is the common factor or the variable factor, will have some benefit of this capital growth. We may consider the impact of the capital stock change on the PPF also. So initially the green line, the light green line was the PPF. Initial equilibrium was at point E1, therefore the country was producing Q1M of manufacturing commodity and Q1F of food. Now as capital stock is changed, then the PPF will rotate towards QM axis, because the increased capital stock will increase the maximum amount of the manufactured output to be produced. Price ratio is remaining unchanged, therefore the new equilibrium will be attained at E2, where a price line which is parallel to the original one is touching the new PPF. So clearly food production is falling and manufacturing goods production is rising. So therefore when the capital stock is changed, there is a significant impact on the production also, just like the earlier case. Not only the employment changes, there is some impact on the real returns to the factors of production, but there is a distinct impact on the production of the two commodities also. We can definitely check that what happens if the endowment of land increases. Then the VMPL curve will be shifting and shifting upward, so that the wage rate will increase, but here the impact on the specific factors will be different. Labor, no doubt, will be better off. So it is actually the advantageous position of the variable factor. So it will be having a beneficial impact in case of capital growth as well as in case of land growth. However, the specific factors will suffer or will become better off depending on which sector is experiencing the growth. If land increases, then definitely the specific factor for the food sector will be better off, whereas the specific factor of the manufacturing sector will be worse off. So we get a result which is very much similar to the Rybczynski type of result that we obtained earlier. Here also, if the endowment of capital increases, then the output of that sector which uses capital as its specific factor will also increase, whereas the output of the other sector will go down. So similarly, we shall have the result for the case where the land increases. Now we consider if the availability of labor is changed. Now when the availability of labor changes, then the increased labor may go to either the manufacturing sector, or it may go to the food sector, or it may be distributed equally or unequally between the two sectors. So here we are considering only one case where the increased labor is going to the manufacturing sector. So as the increased labor goes to the manufacturing sector, the OM will be shifting towards left. So therefore PM is not changing, MPL M is not changing, but the VMPL curve is shifting towards left to PM MPL M star. So therefore equilibrium changes from E1 to E2, wage rate falls from W1 to W2. Employment increases in the food sector, no doubt. Now what has happened to the workers? Workers are unequivocally worse off. Why? Because wage rate has fallen but prices are unchanged. So W by PM has fallen, W by PF has fallen. So workers are unequivocally worse off. the impact on owners of capital is indeterminate, because after the increase in the employment of labor in the new equilibrium, the amount of labor used in the manufacturing sector may increase, decrease, or remain unchanged, because initially the employment has increased, but after the first round change there has been some decrease in the employment of labor in the manufacturing sector. So that is why it is not sure that what has happened to the total employment. Therefore, it is not sure that what has happened to the marginal productivity of capital. So we say that impact on the owners of capital is indeterminate. However, if we consider the landowners, then we find that the food sector has gained in terms of employment. So as employment increases in the food sector, marginal productivity of land will increase and the landowners are definitely better off. So if the labor grows and if it goes to the manufacturing sector, then most interestingly it is the other sector whose specific factors are better off. So in this context it is the landowners. However, the variable factor will definitely be worse off in this context, but the impact on the capital owners is indeterminate. So therefore, if we consider the variable factors, then variable factors are better off if there is a growth in the specific factors. However, they are worse off if there is a growth in the variable factor itself. There may be some other cases of labor increase as I have just discussed. So increased labor may be used in the food sector, or it may be used in equal or unequal proportion in the two sectors. So in each of these cases, the interested readers might find out the results. Thus far, we have considered the pre-trade equilibrium in the home country. Similarly, we can derive that in the foreign country. What has happened if the prices change and the endowments change? Of course, these results have implications for policies as well as for the trade policies. So now we shall be moving on to the trade in the specific factors model. What is the basis for trade and how the gains from trade will be distributed? So let us now assume that there are two countries, home and foreign. They have the same relative demand curve. Therefore, the only source of international trade is the difference in the relative supply. Now, the relative supply might differ if the countries differ in terms of either the technology or the factors of production. So, here we have three factors of production: capital, land, or labor. So, now we make the assumption. We suppose that home has more capital per worker than foreign, whereas foreign has more land per worker than home. Therefore, the home country's relative supply curve Qm by Qf would lie to the right of the foreign country's relative supply curve. For any relative price ratio Pm by Pf, therefore the home country will produce relatively more of Qm. And this difference in supply of the two goods will lead to the difference in the relative prices. So therefore, the pre-trade relative price of manufacturing goods in home is lower than the pre-trade relative price in foreign. We may consider this diagram also. So RD gives us the relative demand curve which is same in the two countries. On the horizontal axis we are measuring Qm by Qf, and on the vertical axis we are measuring Pf by Pf. So we have assumed that in the home country, capital per worker is greater than the foreign country. and foreign has more land per worker than the home country. Therefore, the home country will be producing relatively more of the manufactured commodity rather than the food. So therefore, home countries, as we have just described, home countries' relative supply curve will be lying to the right of the foreign countries' relative supply curve. So now let us consider the relative demand curve. So RS foreign cuts RD at the point where the price ratio is PM by PF in F, and the RS home is cutting the RD at a price level which is PM by PF H. These two are the two autarkic prices. Therefore, PM by PF in foreign is greater than PM by PF in home. So what is our conclusion? Home has a comparative advantage in manufacturing goods and foreign has a comparative advantage in food. Therefore, as trade opens up, home will export M and foreign will export A. So in this specific factor model, it is the endowment of the specific factor that helps in creating the comparative advantage, which is in sharp contrast to the Heckscher-Ohlin model, where the comparative advantage was created by the factor abundance. So we can find out the effect of an increase in the supply of capital. So for a country with relatively higher capital, the relative supply curve for manufacturing would shift to the right. If there is an increase in the supply of land, then for a country with higher land, the relative supply curve for the manufacturing would shift to the left. However, the effect of an increase in the labor force and the effect on relative output is ambiguous, although both the outputs will increase, but that is ambiguous. So therefore, in the specific factor model, we get the very important results that we have discussed earlier. Factors specific to the export sector in each country will gain from trade, while factors specific to the import competing sector will lose. Mobile factors that can work in either sector may either gain or lose, so they will neither prefer nor oppose free trade policy or the tariff imposition. With the imposition of tariff, the factors specific to the export sector will lose and factors specific to the import competing sector will gain. The impact on the mobile factor is indeterminate. So lastly, we can see that with the specific factor model, both the countries will gain from trade. So we consider these two diagrams. On the left hand side, we consider the PPA for the foreign country, and on the right hand side, we consider the PPA from the home country. In the foreign market, the PPF is steeper because the foreign produces relatively more food and less manufacturing goods than home because of our previous assumption. So we assume that pre-trade PM by PF is PA, production and consumption is at point A. Now we come to the home country. The home country's PPF is flatter as the home produces relatively less food and more manufacturing goods than foreign. Once again, this is based on our previous assumption. Pre-trade price PM by PF is PA. Now PA for the home country is flatter than the price line for the foreign country because of our assumption. So for the home country, the production point is A star. Now trade opens up. So PFT is the free trade price ratio, which is same for both the countries. for the foreign country, after trade, the production point is P and consumption point is C. So PCD is the trade triangle, CD is the import of manufacturing goods, and DP is the export of food. The foreign country after trade consume at a point which is lying on a higher indifference curve. So this implies that trade is beneficial for the foreign country. So trade separates the production and the consumption point, and consumption is now on a higher indifference curve. Similarly, for the home country, with trade the production point shifts to P star and consumption point shifts to C star. So trade separates the production and the consumption point. So P star, C star, S, this is the trade triangle for the home country. C star S is the import of food and SP star is the export of manufacturing goods. So home country also benefits from trade because it consumes at a point which is lying on a higher indifference curve. So that is how we show how trade is taking place in the specific factor model. What is the basis for trade? We have seen that it is the specific factor availability, and how does the countries gain from trade in a specific factor model. We have also considered the impact of free trade on the factors of on the real return to the different factors of production. We have considered the impact of factor growth on output as well as on the real returns to the factors of production. So in some cases we have got some results which are very close to the Hicks-Charolin model, but we should always keep in mind that the results should be in some cases dissimilar, because specific factor model is the short run version of the Hicks-Charolin model. So this is all. The references are given in the description box. If you have any query, then you can always contact me. Thank you for watching.